At Init College, a YouTube channel for high school mathematics education. Mathematics 4, Swedish high school education system. The chain rule. Hi, this is Babak. In this video I am going to solve the following problem for you. Let me read the question for you first. Let f be a function that is differentiable on R, the set of real numbers, such that for every non-zero real number x, 8 times f of x plus 6 times f of 1 over x equals to x plus 5. Let g be a function defined by g of x equals to x squared times f of x. Determine g prime of minus 1. I recommend you to pause the video at this point and try to solve the problem yourself first. If you do everything correctly, what you get as the answer is g prime of minus 1 equals to minus 1 over 14. Okay, now we start solving the problem. So the question here is to calculate the derivative of a function g at a given number of minus 1, where g of x is given by this formula. Of course, f of x is not given to you directly. If you had the formula for f of x, it was a simple problem. You just replace f of x with that formula and multiply it by x squared, and then you can take the derivative of that function. When the differentiation is finished, then you replace x with minus 1 and you are done. The point is that f of x is not given to you directly. You have something about f of x. You don't know the formula of f of x, but you know whatever that function is, that function will actually satisfy this relation. Okay, but let us ignore that for the time being. Let us pretend that I know how to differentiate, pretend to have the f of x. So I would say that g of x is given to be x squared times f of x. I am supposed to differentiate g. So I will start differentiating g. So it becomes g prime of x is equal to x squared times f of x prime. Yes? But then you realize immediately that this is the product between two functions, and I am interested in differentiating a product. So that would be the product rule. So let me just remind you what was the product rule formula. So the product rule tells you that if you have a function f multiplied by another function g and you want to differentiate it, you differentiate the first one and multiply it by the second one itself, and then you add the first function multiplied by the derivative of the second function. So that's the product rule. So I exactly follow that idea. So it becomes the derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. But of course, this becomes equal to the derivative of x is simply 2x. So let me write this implies that g prime of x is equal to, it is 2x times f of x, and then I have plus x squared f prime of x. So that is the formula for my derivative, yes? Okay, but now I am supposed to calculate g prime of minus 1, so this immediately implies that g prime of minus 1 is equal to, I have to replace x with minus 1 everywhere, so this becomes minus 2 f of minus 1, and then plus minus 1 to the 2 f prime of minus 1. So finally what I get is this g prime of minus 1 is equal to minus 2 f of minus 1, and then I have plus f prime of minus 1. Yes, because minus 1 to power 2 is positive 1. So what I understand is this. But this is not the solution to the problem, because I am supposed to find an answer for it. Yes, a number, a numerical value for g prime of minus 1. So in order to answer my question mark, I have to know what this is, what the value of f minus 1 is, and what the value of f prime minus 1 is. If I can calculate these values, then I replace them here and then I am done. Okay, calculating f of minus 1 probably depends on this equation. How should I calculate f minus 1 using this relation? The reason that we are interested in calculating f of minus 1 might motivate us to replace this x with minus 1. Is it possible to replace, am I allowed to replace x with minus 1? The answer is yes, because this relation, according to the assumption, is valid for every non-zero real number x, including x equal to minus 1, which is also a non-zero real number. So I would say that this statement will give me that if I replace x with minus 1, then I will get 8 f of minus 1 plus 6 f of 1 over minus 1, yes, is equal to minus 1 plus 5. So let us see how this will work. The first one I cannot do anything, so let me just write 8 of f of minus 1. And then you see that this problem is actually fine-tuned for this solution, because now 1 over minus 1 is exactly minus 1, not a new number. So it becomes 6 of f of minus 1, and on the right hand side minus 1 plus 5 is just simply 4. But then you see that there is only one unknown in this equation. F of minus 1 8 times, f of minus 1 6 times. So it becomes 14 times. So 14 times f of minus 1 is equal to 4. So this implies that my unknown that I am looking is 4 divided by 14, or if I simplify by 2, it becomes 2 over 7. Yes, so this is the first question mark that I was able to find it. Okay, so this is done. Now I need to find this one here. Of course, this is related to the derivative of the function, but if you see, I have an equation which doesn't involve derivative of f. So this motivates me, if I want to exploit this piece of information to get this value, it motivates me to differentiate both sides of this relation with respect to x. So what I'm saying is that I will start again with this given equation. Okay, and then I differentiate both sides, because this relation holds for all possible values of x, non-zero x's. So it means that these two functions, the one on the left and the one on the right, are equal. So I can conclude that the derivative of this function is also equal to the derivative of the function on the right, yes? Okay, but the derivative of the right-hand side is very elementary. It becomes 1, the derivative of x is 1, the derivative of 5 is 0. But then here you have the sum of two functions, and then you have two constant numbers. So what happens, this tells you that I have 8, the derivative of the first one, which is 8 f prime of x. The second one becomes 6, but be careful. The derivative of the second one is the whole expression derivative. Okay, and on the right hand side I have just simply 1. Okay, I don't know how much do you know about the chain rule. The reason is that there is no difference between f of x prime and f prime of x. Okay, why is that the case? So if you remember, the chain rule tells you this. This is another way of looking at the chain rule. This means that assume that you have the composition of two functions, and then you are interested to find the derivative of this composition. Okay, so what does it mean? This symbol here means you first replace the x in the function f with g of x, you get a function, and then you differentiate. So let me tell you, this means that first replace and then differentiate. But this symbol f prime, if you put prime on top of f exactly and write this, what does this mean? This means first calculate the derivative of f and then replace every x in the derivative of f with g of x. And actually there is no guarantee that these two things are equal. They are not. That is the content of the chain rule. This becomes, the one on the left, replacement and then differentiation, is equal to first differentiate and then replace multiplied by the derivative of what you are replacing. Okay, so this we call it chain rule. The reason that these two are the same, because in this relation, this x is playing the role of this g of x. So then this x is also g of x, but g prime of x is simply 1. So it means that this expression is equal to this multiplied by 1. But because there is no difference between f prime of x multiplied by 1 and f prime of x itself, so you see that these two symbols are actually meaning the same thing. But if I have something else, there is no reason that these two symbols be the same. Actually, you see that they are not. They differ by this factor. Okay? So this is why when I take the derivative, in principle, I should take the derivative of the whole expression. 8 is a constant, it goes out. Then I have to write f of x totally prime. But then there is no difference between f of x totally prime or f prime of x. So this is why I wrote 8 f prime of x. But in the second scenario, in the second case, this is no longer, the derivative of this is no longer equal to 1. So I have to put this one here. So what I'm saying is that I have put the prime on top of both of them. So I'm not just doing it subjectively. I put the prime on top of both of them, but here I can flip the prime inside because of this rule. But here I cannot just simply flip the prime on top of it unless I also multiply it by the derivative of the inner function. Okay, so it becomes by the way, below this video, if you are a little bit doubtful about what I'm saying, below this video you will find 2 links that will take you to my lectures regarding the chain rule part 1 and the chain rule part 2. I recommend you to watch those videos. Okay, so here I will continue. So this becomes 8 f prime of x plus, this one becomes 6. I flip the prime inside, it becomes f prime of 1 over x, but the price that I need to pay is to multiply by the derivative of the inner function. And on the right hand side I will have 1. But of course, this is a famous relation. The derivative of 1 over x can be simply calculated to be minus 1 over x squared. Yes, so 1 over x prime is x to the power of minus 1 prime, and this becomes minus 1 x to power minus 1 minus 1, and then it becomes minus 1 x to power 2. Yes? Okay, so let me write everything that I have here. So it is 8 f prime of x minus, I multiply this positive 6 by this negative 1 over x squared. It becomes negative 6 over x squared, and then I have f prime of 1 over x. On the right hand side I will have 1. So this is a very nice exercise in the chain rule. Okay, now if you go back, you see, do you remember To answer this main question mark, I have to answer this one and this one. I already got this to be 2 over 7, so the problem is to find this one. This motivated me to differentiate the given relation. I differentiated using the chain rule. I got this. But my point is to calculate f prime of minus 1. Again, as before, this might motivate me to replace this x with minus 1. Yes? And this will work, you will see. So let me make it bigger and replace x with minus 1. This gives me 8 f prime of minus 1. Everywhere I see x, I put a minus 1. So it becomes minus 1 to 2, f prime of 1 over minus 1, and then this is equal to 1. But then you see that this problem is actually, as I told you, is fine-tuned for solving it in this way. So it becomes 8 f prime of minus 1. This part is just simply 6. I have a negative sign, so it becomes negative 6 f prime, and then 1 over minus 1 is nothing except minus 1 again. And on the right hand side you will have 1. But this is the same unknown. Yes, I have 8 of it. 8 f prime of minus 1 minus 6 f prime of minus 1 just becomes 2 f prime of minus 1 is equal to 1. And then what I get is f prime of minus 1 is equal to 1 over 2. So that is also something that I needed and I was able to find. Okay, so now if I make it a little bit smaller, so you remember this was the main question mark. So the question mark now is minus 2 times f of minus 1, so it becomes minus 2 times f of minus 1 is 2 over 7. Then plus f prime of minus 1, but f prime of minus 1 is 1 over 2, so it becomes plus 1 over 2. So let me simplify this. It becomes minus 4 over 7 plus 1 over 2. And then you know that the common denominator would be 14. 14 to 7 2 times, you multiply it in the numerator, it becomes minus 8. 14 to 2 7 times, you multiply it in the numerator, it becomes 7. And then you get minus 1 over 14. Yes? So finally, the answer to this problem is found. So g prime of minus 1 is minus 1 over 14. Below this video you will find the link to the PDF file of these notes, together with 2 more links to the videos that are my lectures about the chain rule. That's also a good source if you want to refresh your memory about the chain rule and complete your understanding about the subject. You will also find another link to another solution to the same problem. Here I have used the chain rule to solve this problem, but even if you don't know the chain rule, you can still solve this problem. I think it is very instructive if you can also refer to that video and learn the new technique that I have used there to solve the same problem. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye.